This is our second installment on framing over here, Julius Farms, Lot 1, Audax Revival. Hit the subscribe button, smash the like button, follow us on Instagram. Let's get going, Gilmar. So we're over here at Julius Farms, Lot 1. We only have one more house after this to frame at this project. So we've got the first floor pretty much wrapped up over here into day 4 of framing. Had a little bit of inclement weather that we're fighting off. And we're getting the second floor walls up right now, and then hopefully start getting the roof framed in sometime towards the end of the week. We're gonna have the roofer out here hopefully sometime the end of next week, and then we'll be in pretty good shape to get going on the rough ends. But we're gonna take you through, walk you through some of the pieces of framing, some of the names and terminology. I like to mess the names up. You might mess the names up all the time too. We'll go point some things out. Teach you a name or two. All right, so this is the front of the house. We got the garage over here on the left. This is technically the front door. Got a little bit of framing left here to do on the porch. Gets incorporated with the second floor. It looks like there's a little bit of vaulted ceiling in the front foyer of this home that opens up to the second floor, as you can see here. This structural glulam beam up top here in the front, are the front of our porch, basically. This concrete has yet to be poured. Basically, we pour the walls first, we do the framing, and then we come back and we pour like the secondary slabs for the decks, patios, and porches, as well as like the garage floor. Get poured at that time. Let's go inside, Gilmar. Actually, let's stop here for a second. We were gonna go inside, we're gonna stop here. So going back to the porch framing up here, that beam that's running across here, a lot of the houses, which we can grab a clip of, that are already finished in this home, you see like these large posts that are on the patio holding up the front porch roof. So basically those posts get oriented underneath that beam up there, and they sit on top of the concrete, which you see here after the concrete pad goes in, of course. There's still a little framing left here to do. They gotta close in the doorway, which gets framed in up there, and we'll take you inside right now. We'll go through, just like the typical framing with the names of like the studs and everything like that, and that application of an actual doorway, since this one's not installed yet. This is a pretty good one. Turn around on me here. This is your standard opening. This is a cased opening. There's no doors going right here. So what you're gonna see out here in the framing world. Nothing more to say about it. But you do want to take note that these 2 studs and then these studs right here or these 3 studs rather, and then these 2 studs right here they're different lengths. So these 3 studs, they stop short of what's called the top plate. The very top of the framed wall, top plate. Makes sense. The very bottom of the wall, it's the bottom plate. I mean, you can't make this stuff up. It's that easy. But when you get into the studs, it switches up on you, and you got jacks and kings, right? Your jack studs are the ones that are cut a little short. It's kind of like a deck of cards. The jack isn't as important as the king. But in this world, the jack is more important than the king. Up top here, you have the header, right? That is distributing the weight across the opening. So where you have a wall where there's studs every 16 inches or maybe a little less, where you have a perpendicular transition, the weight is taken from the second floor and it's distributed down into the subfloor and then ultimately into the foundation. But every 16 inches, everything's distributed nice and equally across a large area or a given area. But when you have an opening like this, all that weight from the second floor, the third floor maybe, and then the roof, all has to come down to where normally there would be studs, and it has to go on either side of the opening. So in order to distribute that load or that weight and energy, because gravity, you install a header. So up top here, we have a 2x10 header. You can't necessarily see it, but there are more than just one piece of board oriented in there. We'll use this for an example here. To make a header, you're basically, this is very basic header, you're basically doubling or tripling the wood up and orienting it on its vertical side. So like this is the strongest side of the board because it is the thinnest and there's the most amount of fibers beneath it. Going into tensile strength and things like that, but they basically, instead of having the board flat, They flip it up on the vertical side, the most rigid side and the strongest side. They fill in the entire void with more than one piece. Sometimes you have to add a layer of plywood to make sure that the area is completely filled in up there, because when you start doing drywall or trim applications, you want to make sure that's completely filled in. And you also, for structural strength, not filling that in all the way. In some instances, it's significant, but sometimes it's not a big deal. You just kind of have like a void in there, which you don't want. So this is a structural header. That's actually supporting the second floor across here. Whereas if you come over to this kind of header, that's still strong, but it's not required to distribute the same amount of weight. There's a lot of weight sitting on that wall over there, which requires us to have 3 jack studs and then 2 king studs on the outside of that. On this doorway, which is a bathroom, a powder room, your typical 3.0 door, you're only gonna have 1 jack and 1 king stud, on a 2x4 or whatever your dimension is. Then up top, your header is just simply 2x4s on the flat, giving you something to nail the trim into, and then you just kind of distribute it all into a very simple design. Not necessarily needs to be as strong, because the weight for the second floor is distributed from the wall that's behind you and then across all the way to the furthest wall away from me. So although there is technically weight sitting on this wall, it's not bearing the brunt of the pull of the gravity down to the ground. So you kind of have to look up at the ceiling when you're going through this stuff. If you're in a renovation situation, this is what you're getting into. If you're in a renovation situation, this is a good point to make. If say you're doing a renovation and you go and we get this sometimes. It's like, well, can we move this wall? Is it structural? Is it a load-bearing wall? Can we move it here? Can we move it there? Can we get rid of it completely? And a lot of times the answer is, we don't know until we cut open the drywall. But basically there is no drywall, because this house is being framed right now. If you look up at this wall is the last thing. It's like the second floor is sitting on this, and it's sitting on everything opposite of this. There is nothing out here supporting the weight of the second floor. This is the edge of the second floor. So if we were in a renovation and the customer wanted to move this wall, or maybe take this wall out and make this whole grand entrance here, we would say, well, hey, look, upon removing the drywall, we see that this is this is a load-bearing wall. Everything's structural. This is a load-bearing wall. In order for us to open this up all the way down to here, we would have to take this header all the way across and sit it on jack studs and then king studs subsequently. Right now we have the 2x6 studs supporting the load across there, and the header for this opening stops here. But if we did want to open it up all the way, that's what we would have to do. We would probably also have to upsize the beam as well for the length. That's something you're going to want to talk to your architect or your engineer about. But basically that's what it looks like before it gets drywalled and everything like that. Everything in here is important, so you don't want to just go cutting willy-nilly. But some of the walls inside your house are secondary and not necessarily as important as a primary load-bearing wall like this. If you look over to this wall is the perfect example. This wall is, other than standing up to hold the door and the drywall and be a partition, it's not really carrying weight from the second floor, and here's why. If you look up towards the ceiling, the joists are running from the front of the house to the back of the house. Our load-bearing walls are perpendicular with our joists. And that's just because it has to have something to consistently sit on for like the given length that the floor exists. This wall right here is parallel with the joists, right? So if it were supporting anything, it would only be supporting the one joist that's sitting above it. Right, so if you wanted to take this wall out and move it front to back, you probably could do it without a whole lot of ramification. Where it gets a little tricky is the wall that's in front of it parallel with the front of the house and the back of the house. This wall right here might be keeping that wall from tilting one or leaning one way or the other. So yes, you could remove this wall or move it one way or the other, but you would also want to consider what is it doing to the walls that are actually bearing the weight. This wall right here, as you can see, like we have bracing on the outside of the house as well as bracing here. That's because when we were framing this wall up, if you saw in the video, it could tilt in or out still. So basically you throw these temporary bracing in, you get it plumbed up, you get it level, and everything's good to go. And then you frame off your secondary walls from that. So the secondary walls do provide a little bit of strength in that sense, but as far as providing loads from the top, they don't really do a whole lot in most cases. We'll take you over to the edge here. We'll show you a little bit of like the framing on like the outside of the house and then how it relates to the windows and things like that. And then we'll talk about the last type of stud, which is called a cripple. It's the smallest little studs that support the windowsill or the header over top. If you look over at this exterior wall that is still a lot going on over here. We won't get into that right now. But basically we have our jack studs, our king studs. Header is all the way at the top. And then underneath the header are additional cripple studs. Underneath the sill, which the sill is the piece that runs underneath your window or door opening, those are also cripple studs as well. You don't have to put a whole lot of thought into why they're called crippled studs. Those words were invented before cancel culture. So we're gonna recap. We got jack stud, right, Gilmar? Then we got our king studs, got the sill and the cripple. Up top there, the beam all the way at the tippy top, that's your header. This right here, the framing coming down off the header, it's technically a secondary header supported by cripple studs. The reason being is that like the load has to get distributed over top of the window opening. You want the top plate, typically you want that directly on top of the header if you have an opening, and it makes much more sense to pull your framing down off of the header. If you were to put your header lower in this wall, in theory it would be providing the same amount of support, but in application, I don't think it would be. I think that the framing coming down and putting the header at the tippy top, supporting against the top plate of the second floor, it makes the most amount of sense. That's how I would have done it. You might have seen it where the header is dropped down lower, but this is a clean opening. I like to say stuff like that. Yeah, this opening, this is a square opening. All right, so let's go over here, show you a couple more things before we get out of the way. This right here, come take a gander. This is 3 Paralam or glue lam beams attached together to make a stronger beam member. Individually, these pieces are all extremely strong in terms of lumber. This is in the engineered lumber category. You can't necessarily just go to the lumber yard and pick something like this up. In some areas you can, but usually these are special order items, especially right now in the world. Everything is a special order item. But if you take a look at this, it's unique in how it's made. It's man-made product. Each piece of this board is made up of like very thin sheets of wood. They're about an 1/8 inch thick. Each layer has a adhesive in between it, and then this large compression machine comes and presses everything together. It's insane to watch these things get fabricated. And this is kind of one of the modern marvels of framing engineering, I guess, because back in the day where you would probably use stone or then metal, these engineered members allow us to frame very large openings and distribute that load without having to use metal. So this is maybe not the beam you would use in technicality, but this is kind of probably the beam you would use in style if you were to do a renovation in your home and you would have your contractor do the open floor plan or open floor concept, and you want to open up your kitchen into your dining room. Chances are he's going to have to probably put some sort of beam in the wall or up in the ceiling to support the weight of the wall you're removing. And a lot of times it's an engineered beam like this. Thanks for watching. This is our Learn to Build series. I'm Andrew Mann from Audax Revival. Make sure to share this video with a friend. Hit the subscribe button and follow us on Instagram for more videos.